In this video I'm going to explain what connected bodies are. Connected bodies is just a system of one or more particles connected together. They could be connected together by a rigid object like a rod or a string, it's elastic or inelastic. In our case here, we shall consider particles which are connected by inelastic strings. So why do we say they are inelastic? Because we don't cater for the force due to elasticity or the other force which is given by Hooke's law. So we shall look at only particles which are connected by strings which are inelastic. So before we try an example, when we are solving these problems related with these particles, the first step we do is to resolve forces along the direction of motion. That is, to get the net, we get the net force along the direction of motion. So after getting the net force, we equate the net force to ma, as given by Newton's second law of motion, which says that the net force on an object is the same as the rate of change of momentum, which we simplified and we ended up with F is equal to ma. So however, if an object is placed on a plane, which is on a plane, one thing we must take is that we have to first calculate for the reaction which the particle is experiencing. If you have a particle and it's placed on a plane, so remember to do that. Also, you remember to look at cases where if a particle is placed on a plane, it might be smooth or not smooth. If it is smooth, we should know what to do, because if it is smooth, it means we shall ignore the force due to friction which will drag motion. However, if it is rough, then we shall take in the frictional force, which is also given by coefficient of friction mu times the normal reaction in the particle. So let us begin with this body, which is saying two particles of mass m1 and m2 are connected by a light inextensible string which is pulled out. The heavier particle is pulled by a horizontal force P equals 50 along a rough horizontal plane. The coefficient of friction between each particle and the plane is 0.3. So they need us to get the acceleration of each particle and the tension in the string. So what you should note is that if these particles are put along a horizontal plane, they will all have the same acceleration. Just ignore this spelling error. They have the same acceleration. So first of all we begin by sketching. As you can observe here, this is our sketch. This is the first particle, 4 kilograms. This is the second particle of 7 kilograms. So they are being connected by a string. As you can observe here, there's a string here, and then the 7 kilogram mass is pulled by a force of 50 newtons. Obviously, we assume that if motions take place, it will take place in the direction of the 50 newton force. I think that is obvious, because now we will not expect motion to take the opposite direction. So we assume the motion will take place in this direction. So that's motion to take place in this direction. Now let us try out something. So before we do anything, we shall treat each particle independently. So if we begin with the 4 kilogram mass, this 4 kilogram mass, first of all, it will be pulled by this string, which we have taken to be having tension T. Then the other force acting on it is its weight 4g. This is its weight 4g newtons, and the normal reaction R1, which is due to the weight which is due to the weight which is pressing this surface. Then we shall also take into account the frictional forces. The surface is rough, is given by mu r1. So if we resolve forces perpendicularly to this object, as you can observe, if you draw forces perpendicularly to this, you see that the upward force r1 is equal to the downward force 4g. So r1 is equivalent to 4g, meaning now we can determine our frictional force, which will be mu, which is given as 0.3 times this r1, which you have got as 4g. Then to get the net force acting on this mass, we shall get tension, this tension T minus the frictional force. That one will be the net force acting on the 4g particle. Similarly, the net force acting on the 7 kilogram particle will be given by 50 minus this tension, the tension in this string, and also the frictional force here, which is opposing motion. So these two are opposing the motion, so it will be 50 minus these two. Once we get 50 minus these two forces, the T and mu r2, that will be the net force, so which we shall later equate the net forces to MA. Here in case of the 4g particle, MA is this 4A, this one. In case of the 7g particle, our MA will be 7A. And also, as we had done previously, the normal reaction is equivalent to the weight of the second particle. That's R2 is equal to 7g. So when you substitute, when you simplify both, if you set T minus, now here mu was 0.3, R1 was been got as 4g. When you get this and simplify, you get equation 23. This T is equal to 1.2g plus 4a. When you do the same to this, you get equation T equals to this. So now our problem is solve equation 23 and equation 24 simultaneously using any method. In my case, I equated the two. I don't know that is elimination substitution method. Maybe it's one of neither of the two. So when I equated this to this, I now when I equate T equals to this, to equation this, I remained with A as unknown and then simplified. As you can observe here, I equated them and then simplified to get my acceleration as 1.6055 meters per second squared. When I'm speeding, please, you can pause and you watch through the steps. So if you substitute A equals 1.6055 to either equation 23 or equation 24, either this or this, it will take you to, you will solve for the value of T, which is the tension in the string. So this was a case of an example of two particles being pulled horizontally by a string, connected horizontally by a string. So let us try a different example this time. The second example is saying it is for two particles hanging on a single fixed pulley. So they are saying two particles A and B of respective masses 2 kilograms and 5 kilograms are attached to the end of a light inextensible string which passes over a smooth pulley P. The two particles are held at rest at the same level above the horizontal floor, with the portions of the string not in contact with the pulley vertically. So the system is then released from rest. So if we have two particles of 2 kg and 5 kg being connected by a string of 2 kg, if this is our pulley, and then we have our two particles, this be connected by a string here, and we have the one of kg
on one side, sorry, 5G here, and maybe 2G on one side. So if this is the 5G particle, this is the 5G particle, and here we have the 2G particle. So obviously the heavier particle will pull the lighter one, because 5 kilogram particle, the one of weight 5G, is heavier than the one of weight 2G. So now if you release, it means the motion will take place. The 5G particle will move downwards, whereas the 2G particle will move upwards. So this will move downwards, this will move upwards. So let us first of all begin by making a sketch. When we make a sketch, as you can observe here, we are saying this 5 kilogram particle is heavier than 2 kilogram particle, so it will pull this and then it moves downwards. Then this sketch should also contain the tension in the string. You can observe it is missing. There should be tension in the string. Let us add it there. And the string will be pulled in either directions. The tension is pulling the string apart. So the tension will be of this form. There will be tension here. Sorry. Okay, you have taken note of that. Let me ignore it because it is taking our time. So you can add the tension in the string. Let me try for the last time. Okay. Even similarly, we shall have also tension in the other direction, on this other side of the string. I hope you are internalizing as we are trying to do this. There should be tension, then here, then there. So if now we do the same, if you obtain the net force, for example on the 2 kilogram mass, it will be given by the tension here in the string, for example tension T minus 2G. This is moving upwards, so it means this force T is greater than 2G, so it will be T minus 2J, which we shall later equate to mass equals to MA, which is will be 2A using Newton's second law. We do the same to this one. It will be 5G minus T. Here we are assuming that 5G is greater than tension, and to overcome tension and the particle moves downwards, so that the net force here will be T minus 2J here the net force will be 5g minus t. So if we get the formulas for each of those particles to using Newton's second law, for the first particle to be t minus 2g equals 2a, the second one will be t equals to 5g minus 2a. So our work is simple now. Our work is simple. So what we need to do is to solve equation 26
and 27
simultaneously using whatever method. For example, if I subtract equation 26 from 27, this is what I get. I will get 5g minus 2g, which is 3, then this minus this, which will be minus 7a. So this 0 equals to 5g minus 7a. So if we simplify, I hope we shall get something of this form. We shall get acceleration as 4.2 meters per second squared. So to obtain now the tension, we just get this value of acceleration and substitute in any of these equation. Either you put in equation 26 or you substitute in equation 27. Let's try a different one where we have one particle hanging freely and another on an inclined plane. As you can observe here, I will not read through the question for this time, but you can see have an inclined plane which is inclined at an angle of 30 degrees, and we have a particle of 3 kilograms on the incline and another particle of 2 kilograms. So we are going to assume this particle of 2 kilograms is not, there is no surface here, it is touching here. We shall assume it is not touching this vertical surface. As you can observe in this picture, the vertical surface should not have been there, this one. So here we shall assume this incline, not assuming, but they tell us whether it is smooth or rough. Here they have told us that it is smooth, so it means we shall ignore the frictional force. So before we move on, obviously we are going to they are saying determine the equation of motion for P. To get the equation of motion, before we do it, we shall sketch. We shall make a sketch, and then we put all, and then we put all the necessary. We put all the necessary forces acting on the system. For example, here on this 3 kilogram mass, there is this force 3g sine 30 degrees, there is this other force 3g cos 30 degrees. These are the two components of the weight of this particle. There are two components. Then we shall assume the tension in the string is T. I think they should have told us that the string is inextensible, so that we ignore the elasticity. Then they have told us that the pulley is smooth, meaning there is no friction at the pulley. Another thing we should note, I think that's all. So now if we take forces, for example, on the 3 kilogram mass, we have T minus 3g sine 30 degrees. That will be the net force on the 3 kilogram mass. T minus 3g sine 30 degrees. So if we use now Newton's second law, it means we shall have T minus 3g sine 30 degrees equals to 3a. So, which is this case. Then, as you can know, which is this here, which I've just discussed. So when we do the same to the 2 kilogram particle, our 2 kilogram particle, the net force on it will be 2g minus t. So if we use again 22nd law, 2g minus equals to ma, but m is 2, so it will be 2g minus equals 2. So now our work is to solve 29 and 30 simultaneously using whatever method possible. In my case, I just equated the 2 equations, and I got my acceleration as 0.98 meters per second squared. So if I substitute this, for example, in equation 30, I was able to get, that's, you can either use equation 30 or equation 29. I was able to get tension as 17.64 newtons. So that is for a case of, for that example, where one particle was placed on an inclined plane and another particle was hanging freely, and in our case the inclined plane was smooth, so ignored the frictional force. So we try now to this example where we have one particle placed on a horizontal table, and then it's connected to 2 other particles A and B by 2 strings, and we are taking the strings to be still inextensible. I read through the question, but however, as you can read, as I can summarize, they are saying the table, the horizontal table is rough. Particle C has 4 kilograms. The table is rough, and they have given us the coefficient of friction has 0.65. So the thing is connected by 2 inextensible strings to 2 more blocks A and B. So the 2 more blocks A and B, A is having 3 kilograms and B is having 7 kilograms. As you can observe, each one of them has a string connected to them. So they are saying determine in any order the acceleration of the system and the tension in the string of the 2 particles. So as usual, we are going to determine the acceleration and the tension in the strings. There are other examples which we shall not include in this. So if we begin by by sketching this, and we indicate all the forces. Yeah, particle A, as you can observe, particle A has a weight of 3g, and then I've let the string lifting it to be having tension of T1. Particle B has a weight of 7g and is being lifted by a string which has developed a tension of T2. So by observing these 2 particles, the one with the weight of 7g is more heavier than the one with the weight of 3g. So the motion will take place in the direction of the weight of 7g because it is more heavier than the other one. And this will cause the 7 kilogram mass to move downwards and the 3 kilogram mass to move upwards. So here we shall be forced now to make like 3 equations of motion for each of the particles, and then we solve them simultaneously using any method. So if I begin with a 3 kilogram mass, our net force will be given by T1 minus 3g. That's the net force. When we use Newton's second law of motion, it will be T1 by 3g equals to 3a. When you simplify, you get this expression. This one. So we do the same to the 4 kilogram particle. But here, this particle, it is experiencing, it will move but will experience frictional force which will reduce, drag its motion. So what we shall do, we shall first of all get the value of R, which we can get using Newton's third law, which is saying action and reaction are equal. So the particle is acting on this table with a weight of 4g. So the table will react on the particle back with the reaction R. So if we say upward force is equal to downward force, our R will be equal to 4g. R is equal to 4g. So the other step is now to R is equal to 4g. So the other step is to, like I've indicated here, the other step is now to check, to get the resultant force or the net force. So if motion take place in this direction towards the 7 kilogram particle, it means our net force will be given by T2 minus mu R minus T1. But mu is given as 0.65 and R is, we have got as 4g. Mu is here. So when we now simplify what T2, because we have said T2 equals to T2 minus T1 minus mu R is equal to 4a, where 4a, this is now the net force, which is from Newton's second law. So when we simplify, you get T2 equals T1 plus 2.6g plus 4a. If you simplify the expressions as you can see in these steps, we do the same to the 7 kilogram mass, where we shall assume that 7g will overcome T2 and motion will move downwards in that case. So 7g minus T2 will be equal to the resultant force, which is given by MA. So in our case, our M is 7, so it will be 7a. So now we have come up with 3 equations of motion, this equation 32, 33 and 34. So our work is solve them simultaneously in whatever method possible, and then we shall end up obtaining the acceleration and the tensions in the strings. So in my case here, I equated equation 33 and 34, this and this, equated this and this. So when I equate them, I get T1 plus 2.6g plus 4a equals 7g minus 7a. When we rearrange, I get T1 as 4.4g minus 11a. In this way, I was able to first to eliminate T2 from the expressions. So now I'm going to solve this expression which I've got with the one we had got earlier for the first particle, for particle A. This and this simultaneously. So to simplify my work, I equated this equation to this equation here, so that I have 3g plus 3a is equal to 4.4g minus 11a. Obviously both of them are equal to T1. So when I simplify, I go to my acceleration. A has 0.98 meters per second squared. What does this mean? It means particle of 3 kilogram mass will move upwards with an acceleration of 0.98 meters per second squared. This one will move from left to right with that same acceleration. This one will move downwards still with an acceleration of 0.98 meters per second squared, as you have observed. Then to get the tension, now if I substitute the value of acceleration, if I substitute it in equation 1 which we had got, which was T1 cos 3G plus 3A, and simplify, I will be able to get station 1. Then if I also still substitute the value of acceleration 0.98 in the equation we had got on the B particle of 7 kilograms, if we which we had got, which was this, when I substitute the acceleration here and simplify, I'll be able to get T2 equals to 61.74 newtons. In all cases, I've been using our acceleration due to gravity as 9.8 meters per second squared. So finally, we try out a case where we have a pulley of this kind. So they are saying this diagram has a fixed pulley, this one, carrying a string which has a 4 kilogram mass, and on the other side of on the other end of the string it is carrying another pulley, a pulley A, which itself is also carrying two masses, 1 kilogram and 3 kilogram masses. So as usual, we expect to be asked the accelerations of each of these particles, 1 kilogram, 3 kilogram, 4 kilogram, and pulley A, and also to determine the tensions in each of these strings. In this case, we also have two different strings, so we shall let T1 and T2 to be the accelerations in the strings, T1 to be the one in the string which is passing through over the fixed pulley, and T2 to be the tension on the string which is passed over pulley A, which is not fixed. And I've also let the acceleration, for example, of the 4 kilogram particle. You let some direction first of all before you do this. You can let your acceleration of the particle. If I let it, for example, 4 kilogram, I say it is moving downwards, and here I say this this pulley A is moving upwards. At the end of the day, if I've predicted a wrong direction, I will get negative value. So here you don't worry about the directions, because if we predict the opposite one, we shall get a negative value. So if you get a negative somewhere, it does not mean it's retarding. No, it means the direction you chose was the opposite of the motion of the particles. So again, now we put all the necessary forces on this particle. On the 4 kilogram particle, we shall have our weight 4G and the tension T1 to be acting on the particle. Then here on this pulley, the pulley is being lifted by this string with the tension of T1, and it has another string with the tension of T2 passing over it. On one side we have our 3 kilogram mass, and the other side 100 kilogram mass. So on this system of the pulley A, we assume that the 3 kilogram mass will accelerate, it will pull downwards, so it will move downwards, pulling the 1 kilogram mass, which will in turn move upwards. We assume this 3 kilogram mass is heavier than the 1 kilogram mass. And here the acceleration of 4 kilogram mass to move at an extent of A1. Maybe we begin by resolving the forces individually. So if we begin with the 4 kilogram mass, our resultant force will be 4G minus T1, which will in turn be equal to 4A1, where 4A1 is from Newton's second law. So when you simplify, you get an expression of this type. Now, if we move now to the pulley, which is not fixed, pulley A, however, they told us that pulley A is light. As you can observe, they say it is a light pulley. The word light is here. So when an object is light, we assume that it is massless, its mass is almost zero. So So the forces acting on this plate, we have this tension T1 and these two tensions T2. So the net force, if we assume that it will move upwards, the net force on the pulley A will be T1 minus T2 minus T2. Again, from Newton's second law, it will be equal to the mass of this pulley times its acceleration, which is A1. But since it is massless, the mass is 0. So T1 minus T2 equal to 0 times A1. When you rearrange, end up with T2 equals to a half T1. That's our second equation. This is the equation of motion for the pulley A. So now we move to particle, to this particle with 1 kilogram mass. However, as you can observe, we have assumed that if the string over it is moving with an acceleration A2, then particle of 1 kilogram to move with an acceleration of A2 plus A1. As you can see, they are moving, all of them are moving up. So it means that particle of 1 kilogram to move with an acceleration of A2 plus A1. Because as it is being pulled by the string at the same time, the pulley is also moving this whole system upwards. So there are two accelerations. Conversely, or similarly, this particle of 3 kilograms is moving downwards. So it means its acceleration will be given by A2 minus A1, because the particle will move downwards, but at the same time the pulley system is being moved up. So there are two accelerations, A2 minus A1, to move with two accelerations. So we have to take both of them into consideration. So if we begin now, if we go back to 1 kilogram mass, here the resultant force is G minus T2. By this will be equal to G, it was T2 minus G. Since it is moving up, so it means this has overcome G. So it is T2 minus G, which if we involve Newton's second law of motion, that its acceleration will be A2 plus A1. So it will be T2 minus G equals to 1 times A2 minus A1, which when you simplify, you get this expression. So we do the same on the 3 kilogram particle, but for it, as you can observe, this acceleration A2 is opposing A1. So its resultant acceleration will be A2 minus A1. So the net force will be 3G minus T2 equals to 3 times the resultant acceleration, which is A2 minus A1. And as you can see in this expression, so when you simplify, come up with equation 40. So these equations 37, 38, 39 and 40. So our task is to solve them simultaneously to get values of A1, T1, T2 and A2. There are 4 equations with 4 unknowns, which must be determined using any method possible. Any. So in my case, I began by eliminating T2 from these equations. So how did I do this? I equated equation 39 to equation 40. You can equate, I began by eliminating A2 by multiplying equation 39 by 3, because if I put here 3, it will be 3T2, 3G, 3A, 3A1. So if we add such, now, it will be 3T2 plus T2, 3G plus 3G, 3a2 plus negative 3a2, 3a1 plus 3a1, which ends us giving us this, so a2 that way is eliminated, and when you simplify, because you have 4t2 equals to 4g plus 6a1, when you simplify this, you should be able, this should be 6, not 4. You should take note of that. So when you are revising, you should know what to change and what not to change. This is 6 here instead of 4, t6. So when you simplify, you will get t2 equals 3 over 2g plus 3 over 2a1. So even though here this expression is wrong, this one is already corrected with the 6. With the 6 here, it's already corrected. So the next step I did was to equate this equation 41 to equation 38, so that I eliminate t2, was to equate this to the equation we had got from the pulley system, so that I eliminate t2. And the expression I got after eliminating t2, I solved it simultaneously with the first equation, which, remember, we have not touched it. So the trick here is simple. If for example I use equation 39 and 40 to get equation 41, so the expression I get in 41, I must not substitute it to 39 or to 40. If I get this, I should not substitute it either to where it came from. Instead, I should apply it to a new, I should solve it or apply it to a new equation which I have not yet touched. So for example, I got equation 41 from 39 and 40. So I must not substitute to either 39 or 40, otherwise it will diminish. So instead, I would substitute to a new expression. So here you can either now, if it has come from these two, so t2 you can now either apply it with equation 38 or equation 37. But in my case, I did with 38 first. So the expression I got, it has come from equation 30. Here now, this last one, it came from manipulating 39, 40, and 41. This is 41. I manipulated 39, 40, and 39. So it means now I have to at least use it to a new equation which I have not yet used. And in our case, I have not yet used equation, the first equation we had, 37. So I solved this with the equation, the first equation, 37, simultaneously to get our acceleration. So in my case, I just repeated just to make my life simple, or to make a miracle. So I finally got our acceleration as g over 7 meters per second squared. You can simplify it by substituting our g as 9.8 meters per second. So finally I have this. Now to get now the other terms, for example, I can get t1 by substituting a1 in the first expression. If I substitute here for a1 here, if I substitute for a1, it means now this will be known, this will be known, so the final thing I will get will be t1. So if I substitute this t1 in the expression we got from the pulley, where we said, where we got t1 something like, okay, we can look at it, we got T2 equals to a half T1. So if I substitute here T1, I should be able to get T2. I don't know whether it's what I did. It's here, I did it. If I substitute here T1, I should be able to get T2. So which I got as 12G over 7 newtons. So the same way I used the end of the equations, because I had already got A1, A2 to solve for T2, which I finally got. So I have T2, so I used them to solve for A2. So I finally got A2 as 4G. So it means our pulley, because there's a question asking the acceleration of the pulley, our pulley will accelerate at an acceleration of A1. You have got A1 as 7G, has G over 7 meters per second. It means our pulley will accelerate at an acceleration of G over 7. Then the 4 kilogram mass will also, but this one, the pulley will move upwards, the 4 kilogram mass will move downwards, but for it will move at an acceleration of still G over 7 meters per second. The value of A we had got, but will move downwards. This pulley move upwards, this one will accelerate downwards using the same value. Then for the 1 kilogram mass, it will accelerate at a value of A1 plus A2. That's it. And will move upwards. What is that? Yeah? To move at the value of A1 plus A2 upwards. So if we add A1 plus A2, I got 5G over 7 meters per second squared. The 3 kilogram mass will accelerate downwards at a value of 3G over 7 downwards. So I've already got the equations, we've already got them. Now, at this juncture, you try by all means and do all the questions which follow. If there are any questions, you can interact or send me a question via the email. Otherwise, I wish you success in